Before we start, I'd like to clear up a few misconceptions. First of all, Greek fire wasn't actually Greek, it was Byzantine. Second of all, it wasn't actually green, it was just regular fire.
Greek fire was an ancient weapon utilized by the Byzantine Empire over 1,000 years ago. It was used in naval warfare and was a substance that could burn on water for long periods of time and could not be extinguished by water, making it an invaluable weapon for the Byzantines. The exact formula for making Greek fire has been lost, as the Byzantines did not want the substance to get into enemy hands, as it was a key factor in the empire's survival. However, many scientists and even other nations, hoping to be able to use it for their own benefit, have tried to recreate what the composition of Greek fire may have been. Greek fire is commonly thought to be a mixture of pine resin, naphtha, quicklime, calcium phosphide, sulfur, or niter.
Because there is no set way to make Greek fire, we ended up doing a lot of research and visiting sites like this, stopping to make this, and this.
The substance that we used when we tried to create Greek fire was naphtha, which is a flammable oil consisting of various hydrocarbons and is similar to gasoline in some ways. We first tested to see how well the naphtha burned by itself, which was done by pouring a small amount of naphtha into a dish and then igniting it.
Oh, isn't that plastic right now?
Should I turn it on? I'm gonna turn it on.
Yeah, someone. Oh, shit. Guys, I think someone should move it away.
When we ignited the naphtha, we found that even though there was a tiny amount, it burned for a fairly long period of time.
That was pretty sick, right?
In the next part of the experiment, we tested to see if the naphtha would burn on top of the water.
The naphtha is able to burn on the surface of water because of how the naphtha is less dense than the water, meaning that when poured onto the water, the naphtha should remain or rise to the surface. The burning of the naphtha is an example of combustion, in which a hydrocarbon in the presence of oxygen forms water and carbon dioxide as a result of lighting the substance on fire. As you can see, the test was quite successful.
We will now follow the story of Billy the Dow. Billy was just a normal Arabian Dow. He had been through a lot, but made it through everything. The lightning storm, crack whoosh boom, and Billy kept sailing and sailing and sailing. But one day, during a lunar eclipse, Billy sailed into the wrong waters.
Let it get going.
What are you gonna do?
We're gonna try to pour it and see if it can burn our sailboat down.
Execute Order 66.
I don't think they're gonna need the Greek fire.
When you put it in, it makes it go higher. Wait, so your Greek fire work?
I mean, it works.
Did it work?
Yeah.
Did it work? It looks kind of shifty to me. Did it work? Absolutely not.
Ding dong, your opinion is wrong.
Did it work? Sure. Did it work?
Uh-huh.
What is it? It's not green.
Wait, what?
What is it?
Most of the time is burning. I don't understand.
Like I said earlier, Dario, you dumb ibus, Greek fire is not actually green. They movies only show that to make it look cooler.
We then put naphtha in a small beaker and ignited it, and then poured the burning naphtha into the water, hoping that it would spread and set the boat and water on fire. As you can see, the test was quite successful.